So this is the video for your flower lab for this week. That's due on Thursday. So we are in the unit called plants, and it's a Saturday, and my grandson is in here with me. So, in fact, I'll show you real quick because I know you guys are curious. He's saying yellow, and don't mess with my flowers. No, yep, they're mine. They're mine. But this is our lab on plants, and specifically, it's a lab on flowers. Okay, so we know that plants can have vascular tissue or they can be non-vascular. So the mosses are non-vascular, but flowering plants are vascular. And vascular plants have three basic structures or three basic organs. They have roots, which of course anchor them to the soil and help to absorb water and minerals from the soil for the throughout the plant. And then they have shoots. So roots are anything below the ground, and shoots are anything above the ground. All right, so with the shoots, they can be divided into the stem and the flower. So you basically you have a root, a stem, and a flower. Now the stem may have branches, but our lab is going to be on about the flower, the fruit, and the seed. If a vascular plant has a flower, then it is an angiosperm. It is in the phylum Angiosperm. And most plants are angiosperms. Okay? So, this lab is on the phylum Angiosperm, and we're doing the lab on flowering plants. Now, the next thing is that we're going to talk about the parts of the flower. So, the flower itself is the reproductive structure. Reproductive structure of the plant. And if a flower has both male and female parts, we call it a perfect flower. So it's perfect. The ones we're going to look at in our lab are perfect flowers. It's a perfect flower if it has both. The female part is called the carpel or the pistil, and the male part is called the stamen. So if it has both the carpel and stamens, because normally you have like a single carpel and multiple stamens, then it's a perfect flower. It has both the male and the female parts on it. And flowers undergo sexual reproduction just like animals do. Plants have sperm and egg. So, Dennis, I'm trying to teach, honey. Yeah, I'm trying to teach. So, they create sperm and they create eggs. Isn't this a wonderful lesson for me to be teaching in front of my 2-year-old grandson? So, basically, here's what you have. You have a flower. Inside the flower, you have the ovary. The ovary will ripen into a fruit. So the flower structure really is designed to protect the ovary, and it's designed to attract pollinators. And then inside of a flower, you have an ovary. It's actually called an ovary, and it contains the eggs or ova. And that ovary, when it's ripened, fruit is a ripened ovary. Okay? And let's see, the other part is the seed. Inside of the fruit is the seed. Okay? So next, you are supposed to do your flower dissection with a lily. So I'm going to talk to you because flowers come in two types two basic types. I mean, they come in more types than two, but just they are classified into whether they have monocotyledons, which is a single cotyledon, or if they have two cotyledons. So a cotyledon is a seed leaf. Seed, S-E-E-D. It's a seed leaf. So a flowering plant is going to either have one seed leaf or it's going to have two. Now it's real easy to tell. Stop it, Dennis. Seriously. It's real easy to tell if you're looking at the seed, whether or not, I'm trying to find my seed. This one right here you might recognize as a black-eyed pea. And my real scientific instrument that I'm going to use is my paring knife. This is actually my grandmother's paring knife, and my mother said it is like, I mean, you can tell it looks like it's really cheap, but my mother always told me it was the best paring knife she ever had, and I use it now. It's my favorite one. But so if I cut this in half, I'm going to do this real carefully. If I had like okay, I finally got the little black-eyed pea cut open in half, and you can see that there are two halves. I'm trying to put them to where you can actually see them like opposite each other. Anytime you have a seed that has two halves, like a lima bean or a kidney bean or a pinto bean or a black-eyed pea, any of those types of seeds, or a peanut is another example, those are called dicotyledons, and we're going to, or eudicots, we're going to make a little table. So if it is like, I want to show you some things about this corn, but if it's like a corn kernel, so I'm not going to cut it up, you can't cut it into equal halves. It's one kernel, and it only has one cotyledon inside of it. So it's not in two parts. Okay, so I'm going to move my black-eyed peas. We're going to make a little table, the monocotyledons and the dicots, the eudicots. You can just call them dicots. One thing that's different is that monocots have one cotyledon, one seed leaf, and eudicots have two cotyledons. And what this means is there are two halves of the seed. There's another thing, the veins in a monocot, in the venation or the veins, the vascular, well, they're, we call them veins in leaves. The leaf venation is parallel. Can you see that here? Can you, hold on. See that the veins are running parallel from here to here. All of the veins in this leaf are running parallel. Now you can see it pretty good. Okay, so that is typical of a monocot, whereas, I'll show you this one, which is going to be harder to see, but let's see if I can flatten it out. This one, it's hard to find plants this time of year, especially flowers, but this one, the veins don't run parallel, they run in a branching pattern. If you were to be able to see up close and look at those veins, they run in a branching pattern. So in monocots, what we say is that they have parallel venation. And eudicots have branching veins. Okay, another thing has to do with the flowers. The flower parts of monocots, the flower parts are in threes or multiples of threes. So like you can have 3 petals or 6 petals or 18 petals. And same thing with the female, the seeds are going to be multiples of threes. The stamens, the male parts, are going to be in multiples of threes. But in a eudicot, flower parts are in multiples of 4s or 5s. And sometimes that can get confusing because if you had a flower with 15 petals on it, that would not tell you if it was a monocot or a dicot, because it could be a monocot because it's a multiple of 3, or it could be a eudicot because it's a multiple of 5. You would have to look at other things like the seed, like the venation. And there's one other thing that monocots tend to have that eudicots don't, and that is monocots. Got off track. I'm sorry. The vascular bundles. If you were to cut, for example, this celery, if I were to cut this celery like that, like a horizontal transverse cut, and then look here at the vascular bundles, you can't see them now, but you will be able to see them when you stick your celery into food coloring. But the vascular bundles are just bundles of tissue that either transport water from the roots or transport food down the plant through, like from the top of the plant or from the leaves of the plant down to the roots. So we call them vascular bundles. So in monocots, the vascular bundles are scattered. And in eudicots, the vascular bundles are round. They're kind of form a round pattern, formed a circular pattern around the outside of the stem. So you would see, like for this one, and I'll show you this in a little bit, but you would see little bundles of vascular tissue all along the edge here that kind of go in a pattern. So they have no pattern in monocots, but they do have a pattern in eudicots. Also, the eudicots have a taproot, whereas monocots have fibrous roots. That means there are a lot more roots in monocots, and they're a lot more scattered. And a dicot is going to have one long root with branches out, coming out from it. Like, think about a carrot. A carrot is a taproot. And one other thing, very, very quickly, monocots cannot become trees. If it's a tree, it's a eudicot if it is a flowering tree. Now, we also have trees that are gymnosperms that don't even produce flowers. But a flowering plant that grows into a tree is always a eudicot. We don't have any monocot trees, okay? So that's it for this little section.